Hello, students! Have you ever wondered what is really going on inside those small cylinders that power your remote control or your toys? Well, today, we are going to dive into the fascinating world of batteries.
Okay, so let's start with a question. You must have experienced this at home. You put a brand new battery in your TV remote, and after many months, even if you've not used it much, the battery is dead. So why does this happen? Let us try to find out.
Now, to understand why batteries die, we first need to understand what they really are. See, they're not just tiny power plants. They are actually carefully controlled chemical reactions, just waiting for the right moment to happen.
So let's pull back the curtain and see what makes a battery tick. The basic idea behind it is actually quite simple. At the simplest level, just think of a battery as a canned chemical reaction. It's a reaction that wants to happen on its own, it's spontaneous, but we have basically hit the pause button on it, and we've stored its energy just waiting for us to press play.
So you can imagine, these chemicals are just waiting for a green light. When you put the battery into your device and switch it on, you are completing the circuit. You are creating a pathway. And this allows the reaction to finally proceed, releasing all its stored energy in the form of electricity.
Now, for your exam, the technical definition is important. A battery is a collection of what we call galvanic cells. You can just think of these as little powerhouses that convert chemical energy into electrical energy, all packed into a neat, portable form.
To really get a handle on this idea, and to make it very easy to remember, let us use a simple analogy.
Just think of a battery as a compressed spring. This simple image is a wonderful way to understand the potential energy that is stored inside.
So let us break this analogy down, okay? A new, fully charged battery, you can think of it like a spring that is compressed very tightly. It's full of stored potential energy, isn't it? Now, when you start using the battery, it's just like releasing that spring. The energy is released to do some work, like powering your device. And what about a dead battery? Well, that's like a spring that has completely uncoiled. It is exhausted. There is no more energy left to give.
Now that we have the big picture, let's zoom in a little bit. Let's see what is actually inside a typical AA battery. What are the chemicals that are making this whole thing happen?
Okay, first, the outer casing of the battery. It is made of zinc. This is the negative end, or what we call the anode, and this is where the electrons come from. It is the source.
Then, right in the middle of the battery, there is a carbon rod. This is the positive end, or the cathode, and it is the destination for all those electrons. The space between the zinc casing and the carbon rod is not empty, of course. It is filled with a thick paste called an electrolyte, which contains another very important chemical, manganese dioxide. This paste, it acts like a bridge, allowing the charged particles to move and completing the circuit inside the battery.
So what happens is, when you put this battery in, say, a flashlight and turn it on, you are creating a path. This allows the electrons to flow from the outer zinc casing through the light bulb and to the inner carbon rod, lighting up the bulb in the process.
So how does all this chemistry play out in the real world? Let's look at some examples you will definitely recognize from your daily life.
A brand new AA battery. When you measure it, it will have a voltage of about 1.5 volts. This number is not just random. It is determined by the specific chemical reaction happening between the zinc and the manganese dioxide.
But here is something very interesting that you might not know. A so-called dead battery is not completely out of juice. If you were to measure its voltage, you would see it's still around 0.8 volts. It's just that this voltage is not enough power to run most of our gadgets anymore.
So why does the voltage drop? It is because as the battery is being used, the chemicals inside it, the reactants, they get consumed. This weakens the chemical reaction, and as a result, the voltage gets lower and lower until it is no longer useful for us.
Now, what about the batteries in our mobile phones and laptops? Those are usually lithium-ion batteries, and they work a little differently. Their key feature is that the chemical reaction is reversible. This means you can run it backwards simply by plugging it into a charger. This is what allows you to recharge them again and again for hundreds of cycles.
Okay, so let's come back to that first question we started with. It's a very common idea, no? You might think that if you don't use a battery, it should last forever on the shelf.
Well, it turns out that chemistry is never truly still. Even when a battery is just sitting there in a drawer, tiny, unwanted reactions are happening inside. We can call these parasitic reactions, and they slowly consume the chemicals and drain the battery's power over time. And this is exactly why you will see an expiration date printed on the battery packaging.
All right, so let's do a quick recap of the key things to remember about batteries, especially for your exam.
So if you just remember these 3 simple points, this topic will become much lighter. 1.
The core idea. A battery is a canned chemical reaction. 2, the mental image. It's like a compressed spring. And 3, the real-world fact. A dead battery isn't at 0 volts. Its voltage is just dropped too low.
And here is a final thought to leave you with. We have seen that batteries are all about controlled chemical reactions. But what happens when these same electrochemical reactions become uncontrolled? Just think about a rusty gate that's been left out in the rain. But that is a story for another time.